Hi, I'm Janet Doherty, and I proudly serve as the Executive Director of the Environmental Protection Commission. Our mission is to protect Hillsborough County's natural resources, its environment, and the quality of life for our citizens. Over the course of time, our air and water quality have significantly improved. Our water and air quality monitoring networks are among the longest running in the nation, tracking over 40 years of environmental progress. This data is used for research, education, and planning, both nationally and internationally.
EPC has played a major role for 50 years, and we got to continue to make sure that you're around and continue to make sure that our environment is protected for the next 50, 100 more years. You know, we make decisions on politics, and sometimes it's very frustrating. But in your case, it is not. It is about the science. And because our EPC does that so well and so great, there are other agencies from around the state that are calling on us to help them out.
No matter what the future brings, we look forward to meeting the challenges and opportunities that lie ahead with confidence, courage, and integrity.
Come join us!
Hello, my name is Laura Woodard, and I'm a professional engineer and chair of EPC's Engineering Group. On behalf of our agency, I'd like to say that we're excited about participating in this year's 2021 USF Engineering Expo.
This year, our engineers from each of our agency divisions have prepared some amazing demonstrations and presentations to help illustrate some of the many engineering principles and practices that they use each day in performing their job duties. So whether it's the Doppler effect, Bernoulli's equation, or the Hazen-Williams formula, I'm sure you'll find something that piques your curiosity. So sit back, relax, and enjoy the show.
Hi, I'm Diana, and just like my colleagues, I'm an environmental engineer. We all work at the Environmental Protection Commission of Hillsborough County, more specifically, the Air Division. The Air Division is one of 4 operational divisions at the EPC, and we have been delegated by the EPA and the state of Florida to regulate the sources of air pollution in Hillsborough County to ensure compliance with the federal, state, and local regulations.
Hi, I'm Laura. The Air Division regulates over 200 air pollution sources in Hillsborough County. We review permit applications and issue air pollution permits, and also conduct inspections, test audits, and complaint investigations. Some of the air pollution sources that we regulate include industrial facilities such as power plants, gasoline terminals, material handling operations, fertilizer manufacturing, battery recycling and battery manufacturing, painting facilities, and even dry cleaners. All of these facilities generate air pollutants such as particulate matter and volatile organic compounds.
Do you know how many criteria pollutants are regulated by the Clean Air Act? Is it A, 4, B, 5, C, 6, or D, 7? And the answer is C, 6. The 6 criteria pollutants are carbon monoxide, ozone, nitrogen dioxide, particulate matter, lead, and sulfur dioxide.
Hi, I'm Alen. The 6 criteria air pollutants have the greatest overall health effects, especially for children, people with lung disorders, and the elderly. So we measured the quality of the ambient air through a network of sampling equipment. The EPC operates an ambient monitoring network that uses state-of-the-art air sampling equipment to collect, measure, and report air quality data to the state and federal agencies. This data is used to determine how clean or polluted the air is on a daily basis. Air quality advisories are generated when air quality conditions pose a potential health threat for Hillsborough County residents. If you want to find out more about air quality, you can visit our website.
Do you know how many air monitors the EPC operates? A, 32, B, 34, C, 38, D, 42. B is the answer, 34. 20 of the monitors are for national and state air quality standard assessments, and 14 special purpose monitors which collect specific air quality data on pollution problems unique to Hillsborough County.
Hi, I'm Sahan. In order to prevent these emissions from deteriorating the air quality, facilities use control devices to reduce and limit air pollution. One of the most common control devices to reduce particulate matter is a baghouse. A baghouse or fabric filter is a dust collector system that is used as an air pollution control device to prevent dust and solid particulates from entering the workplace or being released to the atmosphere. They have been used commercially since the 1970s. And among the dust collection systems, baghouses are the most widely used because they are both highly efficient and cost-effective. The most important factor in designing an efficient baghouse is the air-to-cloth ratio. That is the amount of total airflow that the baghouse will see from the process divided by the surface area of the filter media. As you can see in this slide, the air-to-cloth ratio will vary depending on the type of baghouse and type of pollution source that you will be controlling.
Hi, I am Felipe and I will be doing a short demonstration of a baghouse operation. Baghouses use fabric filter bags that are arranged in rows and mounted vertically on metal housing. When typically the gases come using the bottom side of the baghouse and they come into the dust system using a blower to bring all that emissions inside the baghouse. The bags are going to collect the PM that comes from the operations and they're gonna exhaust clean air towards stack located on the top of the baghouse. Over time, as the dust begin to build on the bags, there is a lot of different types of cleaning systems that I use to clean the baghouse and make sure that the efficiency of the equipment keep up around 99%.
Various types of cleaning systems are used to remove the dust from the baghouse filters. The cleaning intensity and frequency are very important variables that also affect the baghouse performance. The reverse air baghouses are low-pressure, high-volume cleaning systems. The bags are cleaned by isolating the chamber and reversing the flow of air to the bags. These type of baghouses are compartmentalized, which allows for sections to be cleaned without shutting off the whole system. The cleaning action is very gentle, which decreases the wear and tear on the bags. Shaker air baghouses are cleaned by mechanically shaking the bags. Their design and operation are simple, and they can be compartmentalized to allow sections to be cleaned without shutting off the whole system. Jet pulse baghouses are the most common type of particular air pollution control equipment found in industrial facilities. Their bags are cleaned using high-pressure pulse of air. The cleaning mechanism allows for the baghouses to be cleaned while the system is online. In comparison to the shaker or reverse air baghouses, their cleaning mechanism is more complete, which allows to extend the life of the bags, and it can operate at lower pressure drops with lower space requirements.
Scrubbers are one of the main devices that control gaseous emissions, especially acid gases. Scrubbers can also be used to control particulate matter emissions. There's two types of scrubbers, wet scrubbers and dry scrubbers. Wet scrubbers are air pollution control devices that use liquid to wash unwanted pollutants. Dry scrubbers, on the other hand, use solid substances, generally in a powdered form, to remove harmful components. Wet scrubbers will consist of an open vessel and one or more sets of liquid spray nozzles that distribute the scrubbing liquid. Typically, the flow is countercurrent, with the contaminant gases entering near the bottom of the tower and flowing upward, while the liquid enters near the top and flows downward. The most important design parameter when designing wet scrubbers is the liquid-to-gas ratio. As you can see, these are typical ratios for different types of wet scrubbers.
Hi, I'm Noel Moreira. I will be doing a demonstration for a wet scrubber operation. The wet scrubber we have for demonstration today has a packed bed, which is filled with packing material that provides a large surface area for liquid particle contact. Typically, packing material is made of plastic. Dirty gas enters from the bottom and rises up through the packing material, making contact with the scrubbing liquid, draining down through the packing bed, and the clean air exhausts into the atmosphere. Wet scrubbing works via the contact of target compounds with the scrubbing solution. Solutions may be simply water or solutions of reagents that specifically target certain pollutants.
We hope you enjoy watching this video and that you learn about air quality and the EPC. It takes not only our work at the agency, but also the collaboration of industrial facilities and the participation of citizens in this county to ensure that we maintain a healthy environment. If you want to learn more about the EPC and air quality, please visit our website. From all of us at the EPC, thank you for watching.
Hi, I'm Charles Neal, and I'm with the Wetlands Division of Hillsborough County EPC, and I'm here to introduce some facts about wetlands and the engineering behind developing around wetlands.
Wetlands, as defined by Florida statutes, are those areas that are inundated or saturated by surface water or groundwater at a frequency and a duration sufficient to support, and under normal circumstances do support, a prevalence of vegetation typically adapted for life in saturated soils. This means a wetland is defined by its soils and vegetation as well as the hydrology. The 4 types of wetlands that can be found in Hillsborough County include riverine wetlands, wet prairies, hydric hammocks, and salt marshes and mangrove swamps. The defining characteristics of the riverine systems is the presence of flowing water, stratified soils, and forests dominated by cypress trees. An example of a riverine wetland in Hillsborough County is Lettuce Lake Park, which has jogging and bicycle trails, boardwalks, canoe rentals, and playground and picnic areas. Wet prairies are found along the margins of cypress swamps. The soils are frequently saturated but may be dry for a portion of the year and are typically nearly level, poorly drained fine sands that support a diverse community of plants, including many rare and native species such as orchids and carnivorous plants. Brooker Creek headwaters is an example of a wet prairie. Of the 1,111 acres in the preserve, 62 acres are wet prairies. Hydric hammocks are found on low, flat sites that are periodically flooded by adjacent rivers and streams. These areas are typically inundated for approximately 60 days per year. Soil types within hydric hammocks are usually acidic to slightly alkaline, and organic matter is generally low. Hydric hammocks are dominated by towering live oaks, laurel oaks, and cabbage palms. They may also contain a rich diversity of other temperate hardwood tree species. Alderman's Ford Conservation Park includes approximately 1,400 acres of protected lands along the Alafaya River. The Alafaya River is our county's largest watershed, providing drainage for about 270,000 acres. The park includes a 1.8-mile paved loop trail and boardwalk along the river and 3.5 miles of other hiking trails. Please verify with the park if the trails are open during the COVID pandemic. Salt marshes or estuarine wetlands, often found on low-energy shorelines and in bays and estuaries. The hydrology is driven by daily tidal fluctuations and wind events. Soils can include muck, sand, or limestone, and sediment accumulation ensures that marsh depths do not get too deep. Salt marshes are treeless and vegetation is dominated by the salt-tolerant grasses, rushes, and succulent species. A rare and unique microhabitat called a salt barren or salt dune often forms in areas of the salt marsh where slight depressions exist. Upper Tampa Bay Park consists of 596 acres and hosts both wetland and upland community types, such as tidal marshes and coastal upland hammocks. The park contains an environmental study center and provides other activities such as picnicking, canoeing, and hiking on numerous trails or boardwalks. Keeping wetlands in the natural state is a focus of the EPC. Where development and wetlands interface, it is one of the EPC Wetland Division's primary duties to ensure the wetlands are protected to the greatest feasible extent during the development process. Development occurs for many reasons: new homes, businesses, and infrastructure, to name a few. Large developments, such as a new subdivision, are designed in such a way as to ensure the surrounding homes and businesses do not flood. The protection and presence of wetlands result in lower costs to homeowners by reducing the chance of flooding and lowering the cost of flood insurance. EPC's engineering team reviews plans prior to construction to ensure the hydrology of the wetlands is maintained to the greatest extent possible with the pre-development conditions. The example shown is an area of land consisting of 358 acres. The site has multiple wetlands and 2 creeks. The new subdivision will include 661 new homes, roads, and stormwater management ponds. The stormwater measurement ponds provide a temporary holding volume during storm events to minimize flooding. The ponds shown are designed to discharge runoff at a rate to ensure there is minimal change to the hydrology of the wetland. The runoff is treated for floatable contaminants such as oil prior to discharge to the wetlands for filtration and transportation of the runoff away from the homes and businesses. STEM courses can help prepare you for a wide variety of career fields. It takes science and engineering working hand in hand to protect the resources of Hillsborough County.
Hello, my name is Cindy Santoris, and I am a professional engineer with EPC's Water Division. As a permitting engineer, I, along with several other engineers in our division, are responsible for the permitting and the compliance of industrial and domestic wastewater construction activities in Hillsborough County. We want to make sure that the design and the construction of wastewater infrastructure, such as underground piping, pump stations, and wastewater treatment plants, meet the applicable state and local requirements. Our work primarily involves a close review of construction permit applications, followed by post-construction inspections, certification, and monitoring. Our staff work closely with the public, including professional engineers, utility managers, contractors, and private citizens, to ensure the minimum standards required by the state and local regulations are complied with. Our main goal is to reduce or eliminate any harmful effects to the environment and the citizens of Hillsborough County. One critical piece of information we need to do our job is the accurate measurement of flow rate of wastewater facilities that we regulate. We rely on flow meters, such as ultrasonic flow meters, to gather that information. Clamp-on ultrasonic flow meters are portable measurement units that may be used to measure liquid flow rate in varying applications. They're easy to install because they're mounted outside the pipe wall without breaking the line. There are 2 types of ultrasonic flow meters in use today, and they operate on 2 different engineering principles: Doppler and the transit time. The Doppler ultrasonic flow meter operates on the principle of the Doppler effect, using transducer to emit an ultrasonic beam into the stream flowing through the pipe, and tracking the frequency shift in the sound waves emitted by a moving source. For the flow meter to operate, there must be solid particles or air bubbles in the stream to reflect the ultrasonic beam, like was found in wastewater, sludge, or slurries. On the other hand, the transit time principle calculates the flow rate from a shift in the transit time of the ultrasonic waves. In contrast to the Doppler, the transit time ultrasonic flow meter is best used for clean liquids such as water or oil. Today, one of our engineers at Copic will demonstrate how a clamp-on Doppler ultrasonic flow meter is used to measure flow.
Before we get started, you may be interested in the history of the Doppler effect principle. The Doppler effect was first documented by Austrian physicist and mathematician Christian Johann Doppler in 1842. Mr. Doppler observed that the frequency of sound waves received by an observer are dependent upon the motion of the source or observer in relation to the source of the sound. Before selecting an ultrasonic flow meter to measure flow in a pipe, a few things must be considered to make sure the meter is appropriate for your application. First, since the meter relies on particles or bubbles flowing in the liquid, the lower limits for concentrations and sizes of solids and bubbles in the liquid stream must be considered. Second, the liquid must flow at a rate high enough to keep the particles suspended. Lastly, to obtain an accurate flow rate, ultrasonic flow meters require that the pipe flow full. Now let's take a look at the demonstration of the technology. This is the Doppler clamp-on ultrasonic flow meter. It consists of the flow meter, which contains a computer, and the transducers, which are connected to the flow meter. In this demonstration, water is being pumped through this pipe in this direction, through the transducers, back into the bucket in a closed loop. The water contains particles, which for our demonstration is pepper, which is required to deflect the ultrasonic beam. So this transducer emits an ultrasonic sound wave by emitting an ultrasonic beam into the stream flowing in the pipe. Sound waves are reflected back to the sensor from particles or bubbles present in the flowing material. The motion of particles shifts the frequency of the beam, which is received by the second transducer on the opposite side of the pipe. The flow meter then calculates a velocity based on the Doppler effect or frequency in the returning sound waves, and knowing the diameter of the pipe, which in this case is 0.75, it calculates a flow rate. So the display is showing 1.52 gallons per minute. This is a simple demonstration of a non-intrusive way of measuring flow anywhere you need to know it, out in the field or in a water treatment plant.
Hi, my name is Kimberly Thornton. I'm a professional engineer with the Waste Division of the Environmental Protection Commission of Hillsborough County. The Waste Division is one of the 5 divisions within the EPC. I'm here today to talk a little bit about how we clean up petroleum contamination in the environment. Petroleum contamination can happen in many ways. The most common is from a leaking tank at a gas station, or from surface spills such as someone overfilling their car, or somebody just dumping oil on their property. Once the oil or gasoline or diesel fuel hits the ground, it can end up in our groundwater in multiple ways. Usually, it'll get into the groundwater from rain runoff that will run it through the dry soil and into our water. The groundwater in Florida is our source of drinking water, so it's important for it to get cleaned up. One of the ways in which we clean up the contamination is through the use of an air sparge and soil vapor extraction technology. I have a little display here of an air sparge well. I'm going to talk a little bit about how it works. Air sparging is the process of pumping little bubbles into the ground through a little well in order to contact contaminated water. As the bubbles rise up through the groundwater, they contact the gasoline or diesel fuel or oil, and that contamination wants to move from the water and into the air. It's just the same as when you smell gasoline when you're pumping gas at a gas station. That's where it goes from the liquid gasoline into the air phase. As that contaminated bubbles rise up into the dry soil, we use something called soil vapor extraction, which is a large vacuum in order to extract that dirty air. The dirty air is then taken through a filter, just like the filter in your vacuum, and it's discharged clean on the other side. This is a very cost-effective technology, and it's very low impact in order to clean this water up without impacting the business itself. You've probably seen plenty of these systems at gas stations without even realizing they were there. This technology can be used all throughout the state of Florida in order to clean up the contamination, which is very important in order to make sure that we have clean drinking water moving forward.
hope you have enjoyed hearing from our EPC engineers and learning about the many specialties in various areas of environmental engineering, including our air, water, waste, and wetland divisions. Whether conducting inspections, issuing permits, or monitoring numerous engineering operations throughout the county, our engineers incorporate sound engineering principles and practices into the framework of their daily work activities. This helps EPC to ensure that our county's valuable resources will be here today, tomorrow, and generations to come. Thank you for joining us, and we hope to see you here next year.